Students, in the previous chapter, we learned the effects of force in various situations. When we explore the effects of force a little deeper, we find that in many situations it is not just the force but another physical quantity called pressure that comes into play. So in this chapter we are going to learn about pressure, fluid pressure and applications of pressure. Look at the pictures below to understand the pressure better. The first, why is it necessary to pressurize the cabins of high-flying aeroplanes? Second, why does the balloon burst? Third, which end of the track pin should be used for pinning up the notice board? The answers are, it is necessary to pressurize the cabins of high-flying aeroplanes because plane flies at high altitude, the air pressure is very low there. Second, the balloon burst because of too much air is blown into it and the sharpened end of the track pin should be used. So, we are going to discuss about pressure in details. So, what do you mean by pressure? Let's see. Pressure is defined as force per unit area. That is, force will be in numerator and area will be in denominator. Force is measured in Newton and area is measured in meter square. So, the SI unit of force is Pascal and the short form is P and A, capital P and small a, or you can say the other unit of pressure is Newton per meter square. So, pressure क्या है? Pressure is defined as force acting on unit area, or you can say force per unit area is known as pressure, and SI unit of pressure is Pascal and another unit is Newton per meter square. Now let us see variation of pressure. The pressure depends upon two main factors. The first one is force and the second one is surface area. Students, the force and pressure are directly proportional to each other. डायरेक्टली प्रोपोर्शनल का मतलब कि अगर हम फोर्स इंक्रीज करेंगे तो प्रेशर भी इंक्रीज होगा और अगर फोर्स को डिक्रीज करेंगे तो प्रेशर भी डिक्रीज होगा. और सरफेस एरिया जो है वो प्रेशर से इन्वर्सली प्रोपोर्शनल है. मीन्स अगर हम सरफेस एरिया को इंक्रीज करेंगे तो प्रेशर जो है डिक्रीज होगा और अगर हम सरफेस एरिया को डिक्रीज करेंगे तो प्रेशर जो है वो क्या इंक्रीज होगा. सो दीज आर द टू मेन फैक्टर्स ऑन विच द प्रेशर डिपेंड्स. The first one is force and the second one is surface area. So what are they? Increasing the force on an area increases the pressure produced, and second, increasing the area over which a particular force acts decreases the pressure produced. Means अगर हम force को increase करेंगे तो प्रेशर इंक्रीज होगा और अगर हम एरिया को डिक्रीज करेंगे तो प्रेशर जो है वो इंक्रीज होगा. दैट मीन्स दैट इज फोर्स इज डायरेक्टली प्रोपोर्शनल टू प्रेशर and surface area is inversely proportional to pressure. Now let me explain by taking an example of shoes. Here I have taken an example of sewing needle, stilettos and sport shoes. In sewing needle and stilettos, the area is less, so the pressure will be more. But in case of sport shoes, the area is more, so pressure will be less. So, in compared to sport shoes, the pressure in the stilettos will be more, so it will be uncomfortable to wear for long period of time. But as the area in the sport shoe is more, it will be comfortable to wear for the longer time. So this is the concept of pressure. It depends on force and surface area. Pressure and force are directly proportional. Pressure and area are inversely proportional to each other. Now, let us discuss about fluid pressure. What is fluid pressure? Fluid pressure is a measurement of the force per unit area on an object in the fluid or on the surface of a closed container. अब ये liquids and gases को हम क्या कहते हैं? फ्लूइड कहते हैं. एयर है, वाटर है, तो दे आर टुगेदर नोन एज फ्लूइड्स. तो ये फ्लूइड जो है वो प्रेशर एक्सर्ट करते हैं और उस प्रेशर को हम फ्लूइड प्रेशर कहते हैं. अब हम एक एक एग्जाम्पल लेते हैं किसके कि एयर जो है वो प्रेशर एक्सर्ट करता है और लिक्विड में हम वाटर का एग्जाम्पल लेंगे कि वो भी प्रेशर एक्सर्ट करता है. तो सबसे पहले तुम जैसे पिक्चर में देख रहे हो कि बलून जो है बर्स्ट कर रहा है. अब किसकी वजह से? बिकॉज ऑफ द एयर प्रेशर. जब हम बलून में एयर ब्लो करते हैं तो बलून की वॉल्स पे एयर प्रेशर जो है एक्सर्ट होता है, तो उसकी वजह से बलून ब्लो होता है. अगर हम ज़्यादा एयर ब्लो करेंगे बलून के अंदर तो प्रेशर जो है वो क्या हो जाएगा? इंक्रीज हो जाएगा और इसकी वजह से बलून जो है बर्स्ट हो जाएगा. तो ये एग्जाम्पल है एयर प्रेशर का, दैट इज एयर exerts pressure on the wall of the balloon, and because of the more pressure, when we are blowing more air in the balloon get burst. Now let us take an example of liquid, that liquids also exert pressure. When an object is immersed in liquid, it exerts a upward force on an object. If we try to push a blown balloon in a bucket full of water, we will see that the water is pushing the ball upward. This is because the water in the bucket exerts pressure on the balloon. So this is an example of liquid pressure. Now let us see an activity on liquid pressure.
Let's understand the meaning of the term buoyant force by doing simple experiment. 1. Take a bucket full of water. Try to push an inverted glass bottle into the bucket. What do you experience? When we try to push an inverted glass bottle into a bucket full of water, we have to apply downward force. It means bottle experiencing upward force. The upward force is due to force exerted by water on the bottle containing the enclosed air, opposing the downward motion of the bottle.
So students, from the activity we saw that the water is pushing the bottle in the upward direction, and also in the previous activity of balloon and in the water tub we saw that balloon is also experiencing a force exerted by water. This force exerted by water in the upward direction is known as buoyant force. So what is buoyant force? The upward force exerted by liquid is known as buoyant force, and it is also called as buoyancy. It can be any liquid. Here we have taken an example of water. First, the water and the balloon. In that we were pushing the balloon downward, and in the activity we saw that we are trying to push bottle inside the water. The water in both the cases is applying an upward force, or you can say buoyant force or buoyancy. So the upward force exerted by liquid is known as buoyant force. Now we are going to discuss about variation of liquid pressure with depth. Students, we have just discussed about fluid pressure. What is fluid pressure? Fluid pressure is a measurement of force per unit area on an object in fluid, and in that we discuss about liquid. Now we are going to see how the liquid pressure changes with depth. In the liquid pressure is pressure exerted at a point under a liquid is due to the weight of liquid above it. That means if we go deeper beneath the surface of the liquid, the pressure increases and the liquid pressure is less on the surface of liquid. अब ये लिक्विड प्रेशर जो है किसके ऊपर डिपेंड करता है? डेप्थ के ऊपर. अगर हम लिक्विड के डीप में जाएंगे तो प्रेशर इंक्रीज होगा और लिक्विड के सरफेस पे प्रेशर जो है वो क्या कम होगा. तो इस स्टेटमेंट से हम क्या कह सकते हैं? दैट लिक्विड प्रेशर इज डायरेक्टली प्रोपोर्शनल टू डेप्थ. इफ the depth is more, the pressure is more, and if the depth is less, the pressure is less. इसी वजह से डीप सी डाइवर जो है वो स्पेशल सूट पहनते हैं टू डील विथ एक्सट्रीमली हाई प्रेशर. एज we go deep under the sea, the pressure exerted by water is much greater than at the sea level. जैसे ही हम डीप सी में जाएंगे तो प्रेशर बढ़ता जाएगा. किसके कंपेयर में? तो के सी लेवल के कंपेयर में. जैसे अभी हमने पढ़ा कि प्रेशर इज डायरेक्टली प्रोपोर्शनल टू डेप्थ, तो प्रेशर इंक्रीज होगा जैसे ही डेप्थ जो है वो इंक्रीज होगी. फॉर द सेम रीजन दैट प्रेशर इंक्रीजेज विथ हाइट और यू कैन से डेप्थ, द डैम्स आर मेड स्ट्रॉन्गर एंड थिकर एट द बॉटम देन एट द टॉप टू विथस्टैंड द हाई प्रेशर एट द ग्रेटर डेप्थ. Now, let us see an activity that proves that pressure increases with depth.
Yes, they do. They exert pressure on the base and the walls of the container in which they are enclosed. The pressure on the base will be downwards, and on the walls, the pressure will be sidewards. We can also derive something interesting if we look at the fluid in terms of layers. Say there's water kept in a plastic container. Let's divide the fluid into 5 equal parts. You can see that the second layer of water is holding the weight of the first layer. Similarly, the third layer is holding the weight of the first as well as the second layer. And the fourth layer is holding the weight of the top 3 layers, and so on and so forth. So clearly, the pressure at the bottommost layer is the maximum. There's even a way you can find this out. Near the topmost layer, make a little hole at the side. You'll see that the water flows out from that hole like this. It doesn't roll along the walls, it flows out at an angle. Now let's make a second hole near the layer under it. You'll see that the water flows out at a wider angle as compared to the earlier case. We continue to make holes in the wall and we'll notice that the water literally squirts out. This proves that the pressure at the bottom is much more than the pressure at the topmost layer.
Atmospheric pressure. Now we are going to discuss about atmospheric pressure. What is atmospheric pressure? The pressure exerted on an object by the weight of air above it is known as atmospheric pressure. जैसे हमने लिक्विड प्रेशर में देखा कि लिक्विड एक्सर्ट करती है प्रेशर ऑब्जेक्ट पे, वैसे ही एटमॉस्फेरिक प्रेशर में एयर जो है प्रेशर एक्सर्ट करती है ऑब्जेक्ट पे. सो व्हाट इज एटमॉस्फेरिक प्रेशर? एटमॉस्फेरिक प्रेशर is defined as pressure exerted on an object by the weight of air about it is known as atmospheric pressure. एटमॉस्फेरिक प्रेशर को मेजर करने के लिए हम मर्क्यूरी बैरोमीटर यूज करते हैं. सो मर्क्यूरी बैरोमीटर is an instrument used to measure the air pressure. अब ये एटमॉस्फेरिक प्रेशर जो है ना हमारे अर्थ सरफेस पे अराउंड 100 किलो पास्कल है. सो व्हाट इज एटमॉस्फेरिक प्रेशर अराउंड द सरफेस ऑफ द अर्थ इज 100 किलो पास्कल. बट हम इसे फील नहीं कर सकते हैं और ये प्रेशर इतना ज़्यादा है फिर भी हम इतना इफ़ेक्ट नहीं होते हैं. रीज़न क्या है? हमारी बॉडी के इनसाइड जो है प्रेशर है, किसकी वजह से? हमारी ब्लड वेसल्स और फ्लूइड की वजह से उसकी वो और ये एटमॉस्फेरिक प्रेशर जो है वो बैलेंस हो जाता है. इसकी वजह से हम इतना एयर प्रेशर होने के बाद भी जो है उसको फील नहीं कर सकते. सो द नेक्स्ट इम्पॉर्टेंट पॉइंट इज the atmospheric pressure on the earth's surface at the sea level is about 100 kilopascal, but we do not feel it or get crushed by such high pressure. What is the reason behind it? The pressure inside our body, in the blood vessel and the fluid inside our body is equal to the atmospheric pressure, and because of that they balance each other. So this is the reason. Now we'll see about how atmospheric pressure varies with the height, or we can say variation of atmospheric pressure with height. First of all, what do you mean by altitude of a place? Altitude of a place is the height above sea level. The atmospheric pressure at a place depends upon its altitude and it decreases as we go up. और you can say जैसे ही height जो है increase होगी तो pressure जो है क्या हो जाएगा? decrease होगा. And we know that the atmospheric pressure at a place is a pressure exerted by the weight of the air column above the place. As we go up, the length of the air column above us decreases. That means the weight decreases and the atmospheric pressure is lower at higher places. इसका मतलब माउंटेनियस रीजन पे जो है एटमॉस्फेरिक प्रेशर जो है कम होगा. क्यों? माउंटेनियस रीजन या तो हिली एरियाज में जो है हाइट इंक्रीज होगी तो उसका मतलब लेंथ ऑफ द एयर कॉलम क्या हो जाएगा? डिक्रीज हो जाएगा. और या तो हम कह सकते हैं वेट ऑफ द एयर कॉलम डिक्रीजेस, जिसकी वजह से प्रेशर जो है वो क्या हो जाएगा? कम हो जाएगा. So, as the height increases above the sea level, the atmospheric pressure also decreases. Or we can say in another words कि height और atmospheric pressure जो है वो inversely proportional to each other. That means altitude, or you can say height of a place above the sea level is more, then atmospheric pressure is less. Or if the height of a place above the sea level is less, the atmospheric pressure will be more. So this is how atmospheric pressure or height, or you can say altitude of a place, are inversely proportional to each other. हाइट ज़्यादा होगी तो एटमॉस्फेरिक प्रेशर कम होगा, हाइट कम होगी तो प्रेशर ज़्यादा होगा. Now the question arises, what happens if atmospheric pressure is reduced suddenly? The answer is, if atmospheric pressure is reduced suddenly, then the blood vessels in our body will burst due to the pressure of the blood and other fluid in our body. So this is about atmospheric pressure and the variation of atmospheric pressure with altitude. What is atmospheric pressure? The pressure exerted on an object by the weight of air above it is known as atmospheric pressure, and the atmospheric pressure at a place depends on its altitude and decreases as we go up. So now let us see an activity on atmospheric pressure using rubber sucker.
If you hold your palms together really tight and slowly release, you might be able to experience a force holding your palms together. Do you know why? This is the same idea they use in rubber suckers that is used to hang trinkets on fridge or in toy guns. Let us see how it works. We need good quality rubber suckers and any plain surface. Here we have a petri dish and a mirror. Take the rubber sucker and press it on the surface of the petri dish. Now you can lift the petri dish with the sucker. Now let's try the same with the mirror. It sticks to the mirror surface as well, and you can lift the mirror up. Now try to pull out the sucker. It does not come off easily, but you can pull it off by lifting the sucker from one side and allowing the air to get inside. A rubber sucker works on the principle of pressure. When we press the sucker, the air within the sucker is pushed out, which creates a partial vacuum. The partial vacuum has a lower pressure than the air around it, and this pushes the sucker down. The smooth, thin, flat ends of the sucker creates a seal that does not allow air to enter the sucker, which keeps the pressure difference intact, and this sucker continues to stick. If we want to pull it off, we need to introduce air into the sucker by lifting one side of it.
Pressure gauge is an instrument which is used to measure the pressure, and open tube manometer is a simple form of pressure gauge which is used to measure pressure. Students, it consists of a tube placed in the form of U with a liquid in it, letter U, and one of the arm of the tube is open to the air and the other arm is connected to the rubber tube, which can be connected to the point where the pressure is to be measured. So in the diagram, students, you can see a U-shaped tube is there, and in that tube you can see a blue colored liquid, and one of the arm of the tube is open and other arm is connected to another tube with a funnel at the bottom, and in the middle of the U-shaped tube you can see the scale. It is used to measure the pressure. When there is a difference in the pressure at the end of the two arms of the U-tube, the liquid level in the two arms will no longer will be the same. जब प्रेशर डिफरेंस होगा तब यू शेप में जो लिक्विड होगा ना, उन दोनों का लेवल सेम नहीं होगा, एक में कम और एक में ज़्यादा, और यू कैन से वन साइड ऑफ द ट्यूब विल बी हैविंग अ लोअर लेवल at the of the liquid than the other. The liquid in the arm that experience a higher pressure will push down, and this pushes up the liquid in another arm, and there is a scale provided on which the pressure can be read. तो इस तरह ये स्केल जो है बीच में, उससे हम क्या तो के प्रेशर को मेजर कर सकते हैं. अब ये प्रेशर जिसका भी मेजर करना हो, हम जो फनल वाला एंड है वहाँ पे रखेंगे. अब प्रेशर हमें लिक्विड का मेजर करना हो, या तो एयर का प्रेशर, या तो एयर या तो कोई भी गैस का प्रेशर मेजर करना हो, तो उस आर्म को हम एयर या तो लिक्विड के अंदर डिप करेंगे. और इस तरह से ये ओपन ट्यूब मैनोमीटर से हम उसका प्रेशर जो है मेजर कर सकेंगे. सो दिस इज ओपन ट्यूब मैनोमीटर which is used to measure the pressure of either liquid or gas.
U-tube manometer consists of a glass tube bent to a U shape. Initially, the U-tube is filled with a manometric fluid such that the level of the fluid is same in both the limbs. The manometric fluid in the U-tube can be oil, water or mercury whose density should be known. There are two limbs in the manometer, L1 and L2. A graduated scale is fixed between the two limbs. When both the limbs are exposed to same pressure medium, the fluid level in the two limbs will be equal. Now let us measure the pressure of air trapped inside the tube. The limb L1 is open to atmospheric pressure and the limb L2 is connected with a rubber tube. The rubber tube consists of a clip to make it airtight after the air is blown through it. The pressure of the air in L2 is now greater than the pressure in L1. Now the fluid in the U-tube is displaced to a new position. The difference between the two readings will give height of the fluid level in the tube. The formula for calculating the pressure of air trapped inside the tube is given by P equals rho GH. On substituting the corresponding values in the above formula, we get the pressure value. Let us now measure the pressure of the water column. The limb L2 is connected with the rubber tube. The end of the tube consists of a funnel closed with a rubber sheet. This tube is then inserted into a beaker of water whose pressure is to be determined. The rubber tube with the funnel is pressed down so that the pressure is induced through the rubber sheet to the tube. Now the manometric level in L1 rises and simultaneously the level in L2 falls down. The difference between the readings on the graduated scale is the height h. The pressure of a water column can be calculated as done before. Thus, you have learnt about the pressure measurement using U-tube manometer.
Now we'll be discussing about application of pressure, but before that let us recall about pressure and the variation of pressure with force and area. What is pressure? Pressure is defined as force per unit area, and when we see about the variation, force is directly proportional to pressure. That means if we are increasing the force, the pressure will increase, and if we are decreasing the force, the pressure will also decrease. But area is inversely proportional. That means if area is more, pressure is less, and if area is less, the pressure is more. So now we'll be discussing the applications by taking examples. The ski have a large area to reduce the pressure on the snow, and this ensures that ski do not sink into the snow too far. तो ये जो skis हैं वो कैसे होते हैं, उनका एरिया ज़्यादा होता है, एरिया ज़्यादा होगा तो प्रेशर जो है वो कम होगा, जिसकी वजह से स्नो में जो है वो सिंक ना हो सके. सो skis have large area to reduce the pressure, and we just discussed that pressure is inversely proportional to area. The spikes or the studs on the sole of football shoes have small area. So if the area is small, the pressure will be more. So the pressure produced by the spike increases the sole's grip on the ground. तो फुटबॉल के जो शूज़ होते हैं उसके नीचे सोल पे स्पाइक होते हैं, और स्पाइक्स के एरिया क्या होता है, बहुत ही कम होता है. तो एरिया कम है तो प्रेशर जो है ज़्यादा होगा, जिसकी वजह से फुटबॉल प्लेयर की ग्रिप जो है ग्राउंड पे वो ज़्यादा होगी, और या तो हम कह सकते हैं कि वो खेलते खेलते स्किड ना हो जाए. The next example is of knife and syringe. Both have small area so that small force will be applied for creating a larger pressure. First of all, let us see about the knife. The cutting edge of the knife have very small area. So, a small force produces a large pressure on the cutting edge, and this allows the edges to cut through object easily. Similarly, the doctor uses syringe to take blood from the blood vessel for the blood test. When the plunger of the syringe is withdrawn, the pressure of the blood forces the blood to move into the syringe. So, this is the concept used in knife and in syringe, that is area and pressure. If area is less, the pressure will be more. In case of straw, when we suck liquid through the straw, the air pressure decreases in the straw. The pressure outside the straw pushes the liquid up into the straw, and in this way we are able to suck the juice with the help of straw. Now in the case of heavy bags such of school bags or laptop bags, the straps at the back of the bag are having broader area. This increased area reduces the pressure on the person carrying them. So this is how by increasing the area we are decreasing the pressure, and the person carrying the bag won't feel that much pressure. So here we have discussed few applications of pressure in our day-to-day life. Now let us see few activities based on atmospheric pressure. students, here we end our chapter. Hope the concepts are clear. Please go through the video once and twice. Read the chapter for better understanding. Thank you.